On to Cramers rule. So this will allow you to do problem 29 now when we're all done. So these say to use Cramers rule to solve the linear system. So basically you're getting two equations, two unknowns. We can do it with three equations, three unknowns, but we're not going to do those by this method. Just because this method takes, well, it doesn't take a long time, but it would take a long time if you did it completely by hand. So we've got the system 2x minus y equals -2 and x plus 2y equals 14. So normally we would be multiplying one equation by something and then combining them, whatever. But now with Cramer's rule, what we're going to do is we have basically a matrix that we're going to be setting up. Did y'all have the Cramer's rule in your notes? Yes, it is. Okay. So basically what we're going to do is we're going to set up a coefficient matrix with each variable, and then the denominator is going to be the determinant. So let me do this really fast so you can have a refresher in case you don't have it in front of you. Ax plus by equals e, and cx plus dy equals f. And so basically x is going to be equal to the determinant of apparently I can't write the letters in the right order. D, E, F. Okay, there we go. I was like, what is happening? Oh, these are going to be different letters than I used in your notes, so if you're confused, that's why. So basically, this is going to be whatever the solution is, so C and F, go there, replacing X, and then B and E go here. Okay, so it's the coefficients of whatever variable we're not solving for, and the, like, hold on, let me rephrase that. Whatever the coefficients are here are going in for the variable that we solve for over here. This is all going to be over the determinant of A. Y is going to be A and D this way, and then C and F over here, over the determinant of A. And A is going to be the coefficient matrix, which is going to be the matrix A, B, D, E. So that way you have that in front of you. So now my coefficient matrix for this is going to be 2, -1, 1, 2. And I need to find the determinant of this. So what would the determinant of this be?
4.
Plus 1? Minus the negative, so it'd be plus. So the determinant of that is going to be 5. So my denominator of these is going to be 5. So I don't need to like write that part every time. I can just now write 5 on the bottom. And so this part up here is going to be, we're going to be taking the determinant as well when we set it up. So x is equal to the matrix. So now we're replacing x with -2 and 14. And then we use the y values, -1 and 2, over 5. So what is the determinant of this part up here? Yep. Over 5, which reduces to what? 2. So x is equal to 2. And then for y, I have the matrix 2 and 1 going down there for x, and then -2 and 14 in for y over 5. So what's the determinant of this? 28 plus 2 over 5, which reduces to
6.
And how do we always write our answer for a system of linear equations?
2, 6,
Which is called a what?
oh, ordered pair.
An ordered pair. So always make sure you write your answer that way, even when we're solving using this method or any of the other methods that we end up doing. All right, I'm going to do one more, but there's the only other option for a 2 equation 2 unknown is an odd one, so I'm going to do an odd one. So 31, we have 5x plus y equals -40, and 2x minus 5y equals 11. So I need to find matrix A, which is my coefficient matrix. So that's going to be the matrix 5, 1, 2, -5. What? Oh. So what's the determinant of this? So that's going to be -27. So that'll be my denominator. So then for x, how do I set it up? Or what goes in here?
Oh. It's 11, and then -5.
Yep. So these numbers go in for whatever variable we're solving for. Since we're solving for x, these go in for the x column, and then we use the y values here. So the determinant of the top would be
Positive 200.
So that ends up being, is that 189 over -27? Anybody know that? 7.
You just guessed.
Yep.
Oh, I thought you really knew that. I was like, wow, that was impressive. All right, and then y, what do I put in for y? Or, well, what do I put in, I guess I should say, for this determinant?
11 first.
So I'm solving for y. So the first column should be what?
X.
X, which is
5, 2.
5 and 2. And then this column, if I'm solving for y, what numbers do I put in? -40 and 11. So then the determinant of the top. Over -27. So that ends up being 135 over -27, which is -5. So my solution is
-7, comma, -5.
Yep. Cool. Any questions? Yes.
So, when you put them into the boxes, how do you know what numbers go where?
So if you're solving for x, then we use whatever the solution is. So the numbers that are on the other side of the equal sign are considered like the solution. So those numbers are going in for whatever variable we're solving for. So since we were solving for x, and x is the first column here, so basically that's why I kind of line it up like this. So we're solving for x, so we put those numbers in for x here, copy down the y. When we're solving for y, we put the x values in, and then we use these numbers
Okay.
for y, and then we just find it that way. And if we were doing a 3 equation, 3 unknown, it would be the same way. We would be plugging in, but you would have to do it 3 times instead of just 2, basically. And so I feel like that's a much longer way to solve 3 equations, 3 unknowns, than the method that we're going to learn tomorrow. And so that's why I don't usually do this for 3 equations, 3 unknowns. So anyways, but yes. So now you can do problem 29. And then if you haven't already done, well, if you haven't finished the homework, you need to finish that. And then other than that, you can do the 3.8 notes if you haven't done them already. So, and we're looking at quiz on Friday.